What's the Clelland Heaven Clelland Maths? Today we're going to go through trigonometry and starting this topic with the area of a triangle using trigonometry. I'll go through what the formula for that is, and I'll then go through various examples of using it with a calculator, a non-calculator, and then working backwards from area to maybe calculate an angle. Let's go. So I've got a triangle and I've labelled it ABC. I've not put any sides on, but the first thing I'm going to do is go through how do we label a triangle if we know the angles. So A, B, and C are our angles, and they are capital letters. But to work out our sides, we just start off with any angle and we go straight across till it touches a line. Now that's going to be called A, little a. So I can label that little a. Similarly with B, I can start here and go straight across, and that would be little b. So there's my little b. And obviously with the other one, starting at C, going across, I can label that little c. So the area of a triangle, I'll just say area equals, it's a half AB sine C. And if you're doing National 5 Maths, you are given this at the start of the exam paper, so whenever you have to calculate the area of a triangle in a question, you go and check that formula out. Now I could give you a proof of this quite simply, but I would rather go on and how do we use this in the question. But a couple of things we need to note with this. Although our triangle is labelled ABC, a triangle does not have to be labelled ABC, it could be labelled any letters. So we have to somehow convert any question into this form, and here's how I remember this. If I've got the angle, it's the two sides either side of the angle that I'm using. So there's angle C, I would use A and B. If I was using this angle B, I would use A and C. And if I was using this angle A, I would use C and B. And that is one of the easiest ways to think about this, rather than trying to rearrange sides of things. But you can do that as well, and some examples I'll show you where you rearrange sides. Okay, example 1. Calculate the area of this triangle. Nice and simple one to start with. I've got triangle A, B, and C. I've got angle C. So identifying our sides, if we just use a different colour pen, we can see that opposite A is little a, and opposite B is little b. So we write down our formula. I'm just going to use a big A now for area. A half AB sine C. Notice that A means area, not anything else. So a half AB sine C, we then substitute our numbers in. So that's a half times 9 times 15 times the sine of 60. Now this is a calculator, so you just get your calculator to work that out. A half 0.5 times 9 times 15 times sine 60, making sure my calculator is in degrees. Notice mine gives it as a strange answer, but just ignore that for now. It's the decimal we're looking for. So the answer is 58.456. And it goes on forever, so I'll put ... or we could just round that to one decimal place, say 58.5, and the units centimetres squared. And we're done there. Look at the same thing, but this time non-calculator. It says AB is 5, as shown in the diagram, and it says BC is 3, shown in the diagram. But this time it says sine of B, which is this one here, is 1 over root 2. Notice it doesn't say B is an angle, it says the sine of the B is an angle. So let's write down, if the calculator area is a half AB sine C. Now it doesn't give me sine C, it gives me sine B, but this is where I start using my brain and remember, well, if I've got this angle, I just need to make sure that I use the sides which are opposite, either side of the angle, not opposite, either side of the angle. So don't use this side if we're given it, just make sure you've got this side and this side, and then that can just be A and B, and that can be your sine C. So then we can just sub it in without even writing anything about what they are. I can just say that's a half times the two sides, 3 and 5, times the sine of B. Well, sine of B is all of this, so 1 over root 2. That's why we've told us the sine of B, because I've not got a calculator. It's a little bit tricky, this one, because it's got some suds in it, but let's just give it a go. So we've got a half times 3 times 5, well that's 15 over 2, times 1 over root 2. So that's 15 over 2 root 2. Now, often with a question like this, you'll get asked to leave your answer as a rational denominator. It would probably go on and into surds. So I'll do that for the sake of completeness. But if you want to go back to my surds video, this will kind of show you how to do this. But I times by the denominator over denominator, just the root part, so root 2 over root 2. And that gives me an answer of 15 root 2 on the top over 2 times, and the root 2 times a root 2 is a 2. So that's 15 root 2 over 4. And then just check, can 15 and 4 be simplified? It can't, so I'm finished there. 15 root 2 over 4 centimetres squared, it would be our units, and we'd be done there. Okay, calculating an angle. So we've got DEF triangle, and it tells us that this side's 12 and 10, and we've got this angle here, which we have to calculate, and it tells us the area is 50. So with anything like this, as long as it's the area of a triangle, I write down my formula. Area is a half AB sine C. So in this case, that is our angle, theta, so that becomes C, and that could be our A and B, say. So we could just say that area is a half times 12 times 10 times sine, and we're using this strange thing called theta. But it tells us the area is 50, so we can say that that equals 50. And then we're just working backwards. The easiest way to do these is to work out as much as you possibly can on the left, and then at the end you'll know what sine theta is. My left says a half times 12 is 6, 6 tens are 60, 60 times sine theta equals 50. So now I need to know what sine theta is to work out exactly then what theta is. Sine theta is equal to 50 over 60, or 5/6. Which means that theta is the inverse sine of 5 over 6, which means I use a calculator. Shift sine, 5 divided by 6 is 56.44, so that's 56.4 degrees, and I'm done there. The only other possible thing we could ask if we were looking at angles would be to say that the angle's obtuse instead of acute. And in that case, we'd use the cast diagram, but that doesn't come until much further in the course for National 5 when you do trig equations and trig graphs. So we'll leave it there for now. Let's go on and look at some past paper questions with area of a triangle and look at the whole of every single past paper question on trigonometry and the area of a triangle. So 2014, paper 2, question 13. We've got the picture shows the entrance to a tunnel, which is in the shape of a part of a circle. The diagram represents the cross section, and it says the centre 0. You've got the angle 50 degrees. You have got, this is 7 metres. Calculate the area of the cross section of a tunnel. So this is quite a long, hard one to start us off with. You've got to calculate the area of the arc and then add on the area of the triangle, which is using trigonometry. So check my previous videos on that, half AB sine C. Let's start off with the area of the arc though. So area, remember, equals angle out of 360 times pi r squared. So this time be very careful, our arc is going this way. So that is going to be 310 degrees because 360 minus 50 is 310. So 310 over 360 times pi times 7 squared. We get a mark for knowing the angle, and then we get a mark for working that out, which is 132.56 centimetres squared. So we've done our arc bit, but we now need to do our triangular part. So our triangle bit is a half AB sine C. So for the triangle, I'm using the start of the formula sheet, a half AB sine C, where C is the angle and A and B are the lengths either side of the angle. So it is 0.5 times 7 again times the sine of 50. Doing that in a calculator, we get 18.77 square centimetres. So then our total area, we've got 2 answers so far for 4 marks. Our total area, so that's 3 marks. We get a mark for knowing we need to add to get our total area. So 132.56 plus 18.77, which gives us a final answer of 151.3 square centimetres. SQA National 5 Maths 2015, Paper 2, Question 11 had this question. The tabletop is in the shape of a regular hexagon. The three diagonals are shown in dotted lines below. Each have a length of 40. Calculate the area of the tabletop. So we know that each of these lines here, the diagonals are 40, which means half in it, these will be 20. Now, it's an area of a triangle question in disguise. There's a bunch of triangles here, not all the same size. So if I draw one of the triangles, you should be able to see that it is an isosceles triangle, not an equilateral triangle. And therefore, every angle is 60 degrees. The way to find out it's 60 is because it is a hexagon. There's 1, 2, 3, 4, 5, 6 angles around the centre. 360 divided by 6 is 60. And now we can use area of a triangle. So let's look at this triangle. We can call that C, A and B. That could be A, and that could be B, sorry, and that could be A. So now area is a half AB sine C. So that's 0.5 times 20 times 20 times the sine of 60 degrees. Again, it's a calculator question, so just get your calculator out and work it out. That'll be 173.2 square centimetres. But if we go back to the original question, you'll notice that there's 1, 2, 3, 4, 5, 6 triangles in there. So our total area, we need to times that by 6. Get 1039.2 centimetres squared for our final answer. We have a triangle with trigonometry. This is given to you at the start of the exam paper. Just a reminder that it tells you that the area is a half AB sine C. And we're going to look at a bunch of questions that use this idea. So SQA National 5 Maths 2017 Paper 1 Question 7 had DE is 8, EF is 12, and sine of E is 2/3. Notice this is a non-calculator question, so it's telling you the sine of the angle so that you don't have to work it out already. So the main key point with this is the angle is always in between the two known sides to do the area. So that angle is always our C. So if I want to relabel it, I could call that C, and then that could be A, and that could be B, to give me my little A and my little B here. Well, it's just a substitution. The area is a half of 12 times 8 times the sine of E. Well, C we've called it now, so that would be called sine C. So that gives us 0.5 times 12 times 8 times the sine 2/3. I need to do some work here. 0.5 times 12 is 6. 6 times 8 is 48. So quite quickly we get to 48 times 2/3. And then if you divide 48 by 3, 3 goes into 4 one time. With 1 left over, 3 6 is 18, so that's 16 times 2. So our final answer of 32 square units, which is centimetres. And we're done there. SQA National 5 Maths 2018, Paper 2, Question 17 says, in the diagram below, AOD is a sector of a circle with centre O, and BOC is a triangle. In the sector AOD, the radius is 30 centimetres and the angle is 75 degrees. So we've got AOD. We know that this bit here is 30 centimetres. And it also says in the triangle OBC, O to B is 38, so this whole bit's 38. So we know that we could put a wee 8 here, I suppose. And we know that O to C is 55. So we can draw that in there and say that that's 55 centimetres. What is it asking us? Well, it's asking us to calculate the area of a shaded region. So this is a combination of area of a sector, which is why it's in here, and area of a triangle, which is in the trigonometric section. So let's start off. We can do any one you want, but it's going to be a takeaway, because if I do the whole area of a triangle, I get all the area shaded in, but then I need to take away the area of the sector to get this shaded bit here. So it's a takeaway triangle minus sector. So let's do area of a triangle first. From the start of the exam paper, the area of a triangle is a half AB sine C. So that's 0.5 times, well, remember it's the angle and the two sides either side of the angle. So it's this side 38 and this side 55. 38 times 55 times the sine of 75 degrees. You put all that into your calculator and you get an answer of 1009.39. Bunch of other numbers, centimetres squared. So you've done your triangle, you get a mark for that. You now need to do your sector, so let's go back to our sector work. So we've got angle out of 360 times pi times r squared. So let's write that. Area of sector is our angle out of 360 times pi times, and we need to identify our radius, so let's go back up. The radius is just 30 centimetres, so it's 30 centimetres squared. So you get a mark there for identifying your fraction, and you get a mark for writing down fraction times pi times 30 squared. And if you work it out in a calculator, you get 589.04 centimetres squared. So far we have got 3 marks. There's 2 more marks. The next mark is for working out, you need to do the triangle minus the area and writing that down. So our shaded area is equal to our 1009.39 minus our 589.04. And we get a mark for just writing that down, and then a mark for our final answer, which is about 420.3 centimetres squared. And also I'm putting ... because I've not rounded, but 420 would be fine, or 420.3 centimetres squared would be fine as well. National 5 Maths 2019, Paper 2, Question 13. So for this one, again, we've got our angle, so we'll call that our C, and then the other 2 sides could be our A and our B, and that would be our A and that would be our B. Calculate the area of triangle PQR. So the area is a half AB sine C. So for a mark, 0.5 times 70 times 45 times the sine of 129. You get a mark for the substitution, and then a mark for the final answer. You just get your calculator out and do 0.5 times 70 times 45 times sine 129 in the calculator, and you will get 1224.004. So that would be fine to leave it as 1224 square centimetres. SQA National 5 Maths 2021 Paper 2 Question 8 had the diagram shows a sector of a circle with centre C and radius 14 as shown. Angle ACB is 110 degrees. AB splits the sector into a shaded segment and a triangle ABC. Find the area of a shaded segment. So this is kind of combining 2 things here. We've got area of a triangle using trigonometry, and we've got area of a sector. If I knew the area of the whole sector, then that would give me all of this bit. If I then took away the area of the triangle, it would leave me with this little shaded bit here. So that's going to be my approach. I'll start off by finding the area of the sector, then find the area of the triangle. So area of the sector. Well, a sector is angle over 360 times pi r squared. So our angle is 110 over 360 times pi times 14 squared. Now this was a calculator paper, so we can just quite the thing, get our calculator out and do 110 divided by 360 times our pi times 14 squared, and we get an answer of 188.146, so 188.15 would be fine, centimetres squared. And then we'll do the area of our triangle. So I'm just going to write area of the triangle part. Well, remember that is formulated as a half AB sine C. You're given at the start of the exam paper. So we know that this is 110 and it says sides either side of the angle. Well, I've got 14, but that's going to be the same because it's the radius. So I can label that as 14. So it's just a half times 14 times 14 times sine 110. A half times 14 times 14 times the sine of 110. That gives me 92.089 or 92.09. There's our two answers. So the area of our shaded region is just the difference between those two answers. So area of shaded, I just write equals 188.15 minus 92.09. I just get my calculator and work that one out, and you get 96.06 centimeters squared. And you could round that to another place like 96.1 or whatever, but that's fine. It's not asking us to round in any case, so as long as your answer's not been rounded too much at the start of the question, you're fine. SQA National 5 Maths 2022, Paper 2, Question 6 had this question. Calculate the area of this triangle. Again, it's exactly the same. There's my C, because that's the angle. So any other ones would be my A, opposites A, B, opposites B. Area is a half AB sine C. So that gives me 0.5 times 32 times 25 times the sine of 58 degrees. We get a mark for substitution, it's worth 2 marks, and then a mark for a final answer using a calculator. If we type 0.5 times 32 times 25 times the sine of 58, making sure we've got degrees, we get 339.21 square centimetres. 339 would be an acceptable answer, or 0.2 or 0.21. SQA National 5 Maths 2023, Paper 2, Question 15 on trigonometry, area of a triangle. It says AC is perpendicular to BC, in other words, there's a right angle here. It tells us some lengths, 18 and 6 and 8. It says the area of the triangle is 160 square centimetres. So as soon as you see that area, and it's a triangle, you should be thinking half AB sine C. Check the start of the exam paper. It says calculate the length of A to E, the whole length. So the triangle is A to D to E. This whole triangle is 160. So you kind of need to work out what you're going to do here. Well, area of triangle is half AB sine C, which is when you've got a side and the angle in between. Well, we know the area. We know this side. Can we work out this angle so we can work out this side then, and we don't have one missing? Well, this angle, we could just use SOHCAHTOA from National 4. The sine of A is equal to opposite over hypotenuse. So I can just write sine A is equal to opposite is A over hypotenuse, which is 18. And we can simplify it therefore, but we're going to use it in the question, so we'll just leave it as that. So we know the sine of A. So if I have to make a quick sketch of my triangle, we know this. We're looking for this side. Let's call that our B then. And we know the other side is 18 plus 6, which is 24. So I can just label that as 24. So we know enough, and we know the area of the triangle is equal to 160. So we can just say that a half AB sine C is equal to a half times 24 times some side B times the sine of the angle, which is the correct angle because it is this one, and then I've got these two sides, so that is okay. So that is 8 over 18 sine A. And that equals the area of 160. So we've just got an equation to solve. So working out as much as I can on the left-hand side, that gives me a half times 24 is 12 times B times 8 over 18 equals 160. This was a calculator question. We could use a calculator anytime we want, but 8 times 12 is 96, so that gives me 96b over 18 equals 160. Solving that equation, we get 96b equals 18 times 160. So b is equal to 18 times 160 divided by 96. And we might as well not give ourselves a headache and just use the calculator. 18 times 160 divided by 96 is equal to 30. So B is 30 centimetres. So we can answer the question and say that AE is equal to 30 centimetres. And we're done there. This has been Clelland Maths today. We went through the whole of trigonometry for area of a triangle in National 5 Maths exams. Hopefully you found that useful and helpful. If you do, give it a like and consider subscribing, because we're going to do one of these videos at least every week now. Take care, stay safe, and goodbye.